Hello, I'm back. So, last time you were working on heat problems, the first part, where you found heat and you found mass. Now we're searching for specific heat. I know in the last one you searched for specific heat, but we'll see these ones that are a little bit different and the final temperature. So let's start with the easiest one, which is this one. A piece of an unknown metal with a mass of 36 grams is heated to 125 degrees Celsius and dropped into a 65 cubic centimeter of water at 20 degrees Celsius. The final temperature of the system is 35 degrees Celsius. What is the specific heat of the metal? So this one is practically the same as the one of finding mass. You have your cup here with water and you're putting the metal inside, and then when it's inside, they will both have the same temperature, which is 35 degrees Celsius. We will have a metal that we don't know which one it is, and water. For both, we need mass, specific heat, temperature 1, and temperature 2. Mass, specific heat, temperature 1, and temperature 2. Okay? We have the metal with a mass of 36 grams. 36 grams here, 36 grams here. And your initial temperature is 125 degrees Celsius. Temperature 1, 125 degrees Celsius. And it has 65 cubic centimeters of water. Now, I don't know if you remember in the other video, I said that in 1 cubic centimeter of water at room temperature is 1 milliliter. So it means that we have a mass of water of 65 grams. And the initial temperature of the water will be of 20 degrees Celsius. We already know the specific heat of water, as always, which is 4.184 joules over grams per degree Celsius. We know the final temperature of the system is 35 degrees Celsius. So we have 35 degrees Celsius and 35 degrees Celsius. And we're searching for the specific heat. So we already know that the heat of the water that it absorbs is the same as the heat of the metal, that we don't know which one it is, that really is released. So we put mass times specific heat times delta of temperatures equals mass times specific heat times delta of temperatures. The one of the water will be mass times specific heat times, you go to water and you see that 35 is bigger than 20. So it's temperature 2 minus temperature 1 equals mass times specific heat. You go to the one of the metal and you can see that 125 is greater than 35. So you put temperature 1 minus temperature 2. And we already know that we're searching for specific heat. Okay? So if we're searching for specific heat, it means that mass and temperature 1 and temperature 2, we'll put them together and send them to the other side, dividing. So your formula will be the specific heat of the metal will be mass times specific heat times temperature 2 minus temperature 1 of water divided by mass times temperature 1 minus temperature 2. So specific heat equals 65 grams times 4.184 joules over grams per degree Celsius times 35 degrees Celsius minus 20 degrees Celsius divided by 36 grams times 125 degrees Celsius minus 35 degrees Celsius. So the first thing that you need to do is to do this part right here, this part right here, and this part right here. So we put specific heat equals 65 times 4.184, 271.96. You cancel grams with grams, so you have joules over degrees Celsius, times 35 minus 20, which is 50 degrees Celsius, per 36 grams, times 125 minus 35, which equals 90 degrees Celsius. So now we will multiply this part right here. Okay, now we have specific heat equals 271.96 times 15, 4079.4. You cancel degrees Celsius with degrees Celsius and you have joules, over 36 times 90, 3240 grams times degrees Celsius. So your specific heat it's 1.259 joules over grams per degree Celsius. And this is your answer. Now, if you go to the web and search 1.259, so you'll find that the closest one we have will be the one of iridium and the one of sodium. So it would be probably one of those. Okay? Now let's do problem number 2 as another example. A piece of an unknown metal with mass of 44 grams is heated to 122 degrees Celsius and dropped into 65 cubic centimeters of water at 25 degrees Celsius. The final temperature of the system is 33 degrees Celsius. What is the specific heat of the metal? So we have the metal and we have water. We have 44 grams of the metal. We have 65 cubic centimeters, here, 65 cubic centimeters of water, so 65 grams, 25 degrees Celsius of the water, 122 degrees Celsius of the metal, and the final temperature of the system, which is 33 degrees Celsius. Also, the one of water, specific heat, 4.184 joules over grams per degree Celsius, and we're searching for specific heat. Heat of water is the same as the heat of the metal. Mass times specific heat times delta of temperatures equals mass times specific heat times delta of temperatures. So mass times specific heat, we go with the one of water, which will be temperature 2 minus temperature 1, equals mass times specific heat, temperature 1 minus temperature 2. We're searching for specific heat, so it means that we will bring mass dividing and temperature 1 and temperature 2 dividing. And we keep this one here. So we have specific heat equals 65 grams times 4.184 joules over grams per degree Celsius times 33 degrees Celsius minus 25 degrees Celsius divided by 44 grams times 122 degrees Celsius minus 33 degrees Celsius. We'll do this part, then this one right here, and this one. So we have specific heat equals 65 times 4.184 is 271.96. We cancel grams with grams, so we have joules over degrees Celsius times 33 minus 25 would be 8 degrees Celsius divided by 44 grams times 122 minus 33, 89 degrees Celsius. So specific heat equals, which is 2175.68. You cancel degrees Celsius with degrees Celsius and you have joules, divided by 44 times 89, 3,916 grams times degrees Celsius. So specific heat equals 0.5555 joules over grams per degree Celsius. And again, if you search it in the web, you'll find that the closest one is the Encoloy 800. Now please do by yourselves problem number 3, and now we'll start with problem number 4. Now problem number 4, guys, it's for me the most complicated of the 4 types, okay? So try to pay a lot of attention and write down your doubts for Friday's Zoom meeting. It says, if a piece of iron with a mass of 10 grams and a temperature of 200 degrees Celsius is dropped into a 40 cubic centimeter of water at 20 degrees Celsius, what will be the final temperature of the system? So we have iron here, and we have water here. For both, they're giving you the specific heat of iron. So we have 0.448 joules over grams per degree Celsius. And then you know that you have 10 grams of iron at 200 degrees Celsius. You also know that you have 40 cubic centimeters of water. So you have 40 grams of water at 20 degrees Celsius. And you have the specific heat of water, which is 4.184 joules over grams per degree Celsius. And you're searching for the final temperature of the system. So question mark and question mark. The heat of water is the same as the heat of the iron. So mass times specific heat times delta of temperatures equals mass times specific heat times delta of temperatures. Let's focus on the one of water first. Mass times specific heat. Let's think about the water. We do not have temperature 2, so we don't know which one would go first. Well, think about it. If you insert something that has a higher temperature to the water, it means that water will increase its temperature. So this one will be bigger. So it will be temperature 2 minus temperature 1. And the one of iron is mass times specific heat times, if this one you insert it into water that it's cooler, this one will decrease, so will be smaller. And you have temperature 1 minus temperature 2. You need to think about the obvious, okay? Now you are searching for temperature 2. So in this case, we can't clear the formula like we've been doing it in the other types of problems. So we will first start with the substitution into this formula. Let's start with the one of the water, which is this one. 40 grams times 4.184 joules over grams per degree Celsius times X, we don't know, minus 20 degrees Celsius equals 10 grams times 0.448 joules over grams per degree Celsius times 200 degrees Celsius minus X. Okay, let's name it X. So the next thing that we need to do will be multiply this part right here and multiply this part right here and copy it again. Is 167.36. You cancel grams with grams, so you have joules over degrees Celsius times x minus 20 degrees Celsius equals 4.48. You cancel grams with grams, joules over degrees Celsius times 200 degrees Celsius minus x. Here we have the variable we're searching for. Now, if you remember in algebra how to multiply these type of problems, you will multiply this one times this and this one times this one. The same here. This one times this and this one times this. Okay? So the first one will be 167.36 joules over degrees Celsius x. Then you have a minus here. So you'll put a minus here and you multiply 167.36 times 20, 3,347.2. You cancel degrees Celsius with degrees Celsius and you have joules equals 4.48 times 200 equals 896. You cancel degrees Celsius with degrees Celsius and you have joules minus 4.48 joules over degrees Celsius x. The next step is to put the variables in the same side of the equation, the corresponding variables. So this one that has the x, I'll bring it to this side, and this one without an x, I'll bring it to this side. Now, as you can see, this one is subtracting, so I'll pass it to the other side adding. This one is subtracting, so I'll pass it to the other side adding. So I'll put 167.36 joules over degrees Celsius x plus, because I'm bringing this one, 4.48 joules over degrees Celsius x equals 896 joules. Here you have a negative sign, so it's passing positive, plus 3,347.2 joules. Now the next step is to add them. So you will add 167.36 plus 4.48 equals 171.84 joules over degrees Celsius x equals 896 plus 3,347.2 joules. We have 4,243.2 joules. Now, what we need is to leave x by itself. So, it means that this part right here, I'm passing it to the other side. How? Dividing. So I have x, which is temperature 2, equals 4,243.2 joules divided by 171.84 joules over degrees Celsius. Your answer is 24.69. You cancel joules with joules, and your answer will be given with degree Celsius. And this is your answer for temperature 2. I will do another example with you. A piece of lead with mass of 21.5 grams at temperature of 100 degrees Celsius is dropped into an isolated container of water. The mass of the water is 132 grams and its temperature before adding the lead is 20 degrees Celsius. What will be the final temperature of the system? You have lead and you have water. They're giving you the specific heat of lead, which is 0.159 joules over grams per degree Celsius. Then you have a mass of 21.5 grams, (100 degrees Celsius). Then they're telling you that the mass of the water is 132 grams. You already know the specific heat. And you have an initial temperature of 20 degrees Celsius. You're searching for temperature 2. So you put your formula: heat of water equals heat of lead. So mass times specific heat times delta of temperatures equals mass times specific heat times delta of temperatures. Mass times specific heat, temperature 2 minus temperature 1, equals mass times specific heat, temperature 1 minus temperature 2. I already explained this part. So you start putting the information. 132 grams times 4.184 joules over grams per degree Celsius times x minus 20 degrees Celsius equals 21.5 grams times 0.159 joules over grams per degree Celsius times 100 degrees Celsius minus x. So we start multiplying this part right here and this part right here. 132 times 4.184 equals 552.288. You cancel grams with grams, so you have joules over degrees Celsius times x minus 20 degrees Celsius equals 21.5 times 0.159 equals 3.4185. You cancel grams with grams, so you have joules over degrees Celsius times 100 degrees Celsius minus x. Now we start multiplying this one times this one and then times this one. The same here, this one times this one and then times this one. So 552.288 joules over degrees Celsius x minus 11,045.76 degrees Celsius equals 341.85 degrees Celsius with degrees Celsius, and you have joules, minus 3.4185 joules over degrees Celsius. Because even though you already canceled here, it's like a new process, so you included x. Now you color everything that has the same type of variable, and you put the same color in the same side. So in here you have 552.288 joules over degrees Celsius x plus 3.4185 joules over degrees Celsius x equals 341.85 joules plus 11,045.76 joules. You add them up, 555.7065 joules over degrees Celsius x equals 11,387.61 joules. Now, let's remember that you're searching for x, so you're bringing this part right here, dividing, and your answer will be 20.4921 degrees Celsius. And that's it. So I hope you understand it. Anyway, Friday we're clearing doubts for it, so try to do it the best you can, guys. Clear doubts with me through Classroom or contact me anyway, and if not, we'll see you Friday. Love you, miss you, see you soon. Bye bye.